So good morning, everybody. We made it. Is everybody excited for the end of the semester? Next week's the last week of class.
Yes, very.
Oh, I'm so excited. I can't wait. It's been a long and weird semester, but it has gone quick, you know? All right. So just a few announcements before we get started. So first up, I'm behind on grading your weeks 12 and 13 assignments. I don't know if people saw, but I haven't released the week 12 assignment grades. I'm going to do those today, hopefully during my office hours right after class. But if I don't get to them, if something happens during my office hours, I'll get to them by Friday at the latest. And your final exam is next week. All right. So all we're going to do on class next week for the final exam is you'll log into our Zoom class meeting, and you'll load up the exam. The exam will be open for exactly 2 hours, and I'll be on the Zoom the entire time in case there are questions that people have, like about, Matt, I don't understand this question, or formatting issues, and then sometimes there might be a typo on the exam, things like that. So you'll be in the Zoom taking it. You don't have to turn your camera on, but the Zoom is there for you to ask questions. You can either turn your mic on and ask me questions during it, or you can post to the chat if you want. All right, so it's going to be different from the midterm. So as I said, it's just going to be an online exam, just like your weekly post-class assignments. You'll log in and, it'll be something like 20 questions or something. All right, so before I get into the topics of that, does anybody have any questions about the final exam?
I have a question. Are there going to be questions like which one of these is a statistic, which is a parameter, those kind of like word questions, or it's just going to be word problems?
Just going to be word problems. So it's just going to be everything from the midterm on. So there won't be anything. Sorry for my yawn. There won't be anything like anything from the first 5-6 weeks of the course. So no definitions or data types.
Okay, I just get confused between what the difference is between a parameter and a statistic. They seem like the same thing to me.
Yeah, totally. So like a statistic is just a value calculated from a sample, and a parameter is a value calculated from a population. So like if you'd have imagine this box is all the WCC students, like every single WCC student. If you were to calculate an average, say average GPA from all the WCC students, that would be a parameter. But if you were to take a small sample of WCC students and calculate their average GPA, that would be a statistic. That's just the difference.
Okay, got it. Thank you.
Mm-hmm. So the midterm is going to be open notes. You can use whatever you have in front of you. You'll use your calculator. I can't police you on the internet, so you can use the internet too. Not that would really help you all that much. So let me go over the topics. Okay, so there's going to be 3 topics on the final exam. Okay, sampling distributions. So we talked about sampling distributions for a mean and sampling distributions for a proportion. Then we talked about confidence intervals. We're going to talk about confidence intervals for a mean, and then confidence intervals for a proportion. And then we did hypothesis testing for a mean and hypothesis testing for a proportion. Okay. So basically you're going to get one question of each type on there. So the questions, though, they'll be like, say, when I say it's like 20 questions. Okay, let's just say it's 20 questions. Okay, the first 3 questions will be about maybe a sampling distribution for a mean. Then the next 3 questions will be about a sampling distribution for a proportion, and so on. Maybe then the next 4 are about confidence intervals for a mean. Then the next 4 are about confidence intervals for a proportion, and so on. Okay. This adds up to 22. So they'll be all in order like that. So there'll be different numbered questions, but the questions will follow in order of each other. Okay. Does that make sense?
Yes.
Yes.
Okay. And then also the exam will be automatically graded for you. So you'll be able to know your exam score immediately. And then basically I'll submit final grades shortly after class. What I'll do is I'll say your final average is up. Let me know if you notice any errors with it. And then I'll submit final grades later that week. Or after instruction ends, actually. So I'll submit on the 22nd. But you will effectively be done next Tuesday.
Woohoo!
I know. Trust me, I'm so excited. Yeah, very, very excited. Although we were planning to put our son in daycare in January, but we're not anymore. So the next semester is going to be rough too. All right. If you look into the classroom, what I wanted to do today is under the week 14 tab, you see this Word document here. Did anybody download it before class? I'm just curious.
Yes, I did.
Yes, I did.
Okay. So this is last year's final exam that I gave. I'm only going to do I want to walk through the first 6 problems with you on the final exam. And then if we have time, I'll go back and do problem number 7. These are a lot of these questions look really familiar from your post-class assignments. And, this is what I gave last spring as the final exam. So you can kind of see like the difficulty of questions that I'm going to ask. So what I wanted to do is I just wanted to walk through the first 6 questions with you. Okay. Cause they go in exact order. The first one is sampling distribution of mean. Second one is sampling distribution of a proportion, and so on and so on. Okay. So have this handy. I hope if you haven't printed it out, don't stress. Just focus on, copying down the answers that I give you. And then, that honestly will be your best way to get ready for the final. And then just spend the next week getting your notes together. Because for as long as I've been teaching, I give a lot of, open notes exams. Students waste a lot of time in class, like just flipping through their notes, trying to find the answer. So spend some time getting your notes together and ready for the exam. Okay, so before I get started going through the actual problems, does anybody have any last minute questions for me? Anybody doing anything fun for their winter break?
Not really.
Quarantining.
I'm absolutely quarantining, and I'm going to catch up on my television, I think. Right, I'm behind on everything.
You should watch The Undoing on HBO. It was pretty good.
The Undoing?
Yep.
Okay, what is it, a sci-fi show?
No, it is a thriller, sort of psychological thriller about a murder.
All right, Undoing.
And there's only 7 episodes, so.
Oh, I like that, actually. I got to watch Queen's Gambit, I think. Did anybody watch that on Netflix?
Yeah, my daughter and I are in the middle.
Is it really good?
It's really good. I really loved it. So you should definitely watch it.
Yeah, that's on my list. And then I want to watch season 2 of The Boys on Amazon. That's on my list.
Good show.
Yeah.
My husband watches it. It's a little bloody for me.
It is a little bloody. I got my wife into it, though. The only show we watch every week is The Mandalorian on Disney+. I haven't missed that once.
Have you ever seen The Good Doctor?
The Good Doctor. Oh, that sounds so familiar.
It's the one with the autistic doctor.
Is he-
He works in a
I
hospital.
have seen that.
And he's like a young boy or something?
He's younger. He has like
Yeah.
crazy, I don't remember what it's called, but his memory is like off the charts, and he's like so smart. But it's a great show.
All right. Yeah, it's kind of like a Doogie Howser, but better. Right? What was the name of that kid doctor in the 80s show? Oh my God, I think it was Doogie Howser. I'm not sure.
That's right.
Yeah.
Doogie. But Doogie was like funny.
Yes. All the 80s shows were good. Oh, the 80s and 90s. What a good time. Wow. Now I sound like an old man. Holy cow. I will check out The Good Doctor, The Undoing. Thank you for the recommendations. As much as I would love to talk about TV for the next 2 hours, let us jump into it, okay? So any other questions then? Okay. So your questions on the exam will go in this order. And just so you know, what I will do on the exam is when you load it up, every problem will have like a title to it. Like it'll say question 1 and then what the problem's title is. And I'll put like titles like this: sampling distribution mean, sampling distribution proportion, confidence interval for a mean, confidence interval for a proportion, hypothesis testing for a mean, and then hypothesis testing for a proportion. Just so you'll know, like you'll know what problem you're on, okay, as a extra little bit of help for you, okay? So if you're ever like, oh man, I don't know exactly how to tackle this problem, it's right there for you, okay?
Thank you.
Yeah, you're welcome. Also, as I get started, I do have the Word document. I just took the problems here and pasted it into PowerPoint so you can follow along that way. And then also have your TI-83 or TI-84 calculator handy. We are going to rely heavily on the calculator to do every single problem, okay? We're going to do nothing by hand, all right? So I'll do half the problems on the TI-83 and half on the TI-84 so you can see the difference. Okay, so here's sampling distribution for a mean. The average outstanding credit card debt for young couples, okay, these are couples that are under the age of 30, is $650. Okay, so right here they're telling you that the average is $650 with the standard deviation. So then they're giving you the standard deviation sigma of $240, okay? So here's the problem. Suppose 100 young couples are sampled. So we're gonna sample 100 young couples. So that's our N, 100. And the average credit card debt is recorded, okay? So I'm gonna define a variable. I'm gonna let X bar here, okay? And it's gonna be the mean credit card debt. For 100 young couples. Okay. It goes on to say, describe the sampling distribution for this sample mean right here, the mean credit card debt for 100 young couples. Okay. I know this was like forever ago. We talked about this in week 7. But does anybody remember? I'm just curious. Remember what I said the most important theorem of the class was?
The central limit theorem.
That's exactly it. And the central limit theorem says, look, as long as your sample size is greater than or equal to 30. So because, sorry, my handwriting's a little bad today. Because N is greater than or equal to 30. The CLT, the central limit theorem, says the sampling distribution of X bar will be what? Does anybody remember?
The same as the mean.
That's mu sub X, but the sampling distribution will be normally distributed with, and now this is what you're talking about. So mean, we denote it as mu sub X bar. So the average of the averages. And what did you say that was equal to? You had it right.
Mu is equal to 650. You mean the number or just the letter?
Either is fine. Yep. So mu sub X bar. So the average of our sampling distribution of X bar will be the same as the population mean. And the standard deviation, we denote it as sigma X bar. Okay. And does anybody remember the formula for that?
Sigma over the square root of N.
Awesome. Thank you. Yep. So you're going to take 240 divided by the square root of those 100 young couples. Okay. So that would be 240 divided by square root of 100 is 10. So it would just be 24. Okay. So just as a pause here, like this question is really hard for me to put into the final exam. So it'll just say things like, you know, will the sampling distribution be normal, true or false? And then it'll say something like, what does mu sub x bar equal? And then I'll have multiple choice. Then I'll say, what is sigma x bar equal to? And then I'll give you a bunch of options. You'll see it'll be a multiple choice question for this. Okay. So now the question says, part B, what is the probability that that sample mean, that x bar, from a random sample of 100 young couples will result in a mean credit card debt greater than $700? So I want to find the probability that x bar is greater than 700. Okay. So I know it seems silly, but does anybody remember what I said helps me on these problems?
Drawing a graph.
Yeah. So what I'm going to do here is I'm going to draw the distribution of x bar. And here's what I know. I know it's normally distributed. It's centered around 650. And I want to be greater than 700. So I'm going to shade to the right. Okay, shade to the right. So I showed you how to do this by hand, but is there an easier way to do this? Does anybody remember? I know it's been like forever.
This is the normal CDF.
Yep. So grab your trusty calculator. It doesn't matter if you have the TI-83 or the TI-84 here. Okay. What you're going to do is do you see the DISTR? So you're going to go second function, DISTR. Yeah, come on. So over here, second function, DISTR. And does everybody on their calculator see the normal CDF option?
Yep.
Anybody
Yes.
else see it? Everybody got it?
Yes, I do.
Okay. Everybody go to option number 2 on your calculator. All right. The TI-83, it opens it up and you have to manually input 4 things. The TI-84 makes it a little bit easier. So this is solved with normal CDF. And there are 4 commands. You need to put in the lower value, comma, the upper value, comma, the mean, comma, and then the standard deviation. Okay, so looking at the graph, can anybody tell me what my lower value is here?
700.
Yep, I want to find the area starting at 700. And then it's going to go all the way to the right. So does anybody remember what I put?
9999.
Yep, 99999. Thank you. And then the mean and standard deviation are right here. Okay, so the mean is 650. And the standard deviation is 24. That's why we found it in the first part. So in the TI-83, unfortunately, what you have to do is you have to press 700 and then comma 9999, comma 650, comma 24. And then you have to close the parentheses. The TI-83 makes it a little bit easier, or the TI-84, excuse me. It just like really lays it out for you. Because remember, mu is the mean and sigma is the standard deviation. So you should see this, or you should have typed in this. Come on, calculator. And were you able to do this get this answer right here?
Yes.
Okay. So what it'll say is a problem like this will be, it'll say something like, plug in your answer and go to 4 decimal places. Okay. So whenever there's a problem that says go to 4 decimal places, you'll round to 4 decimal places, obviously. But what I will do is I will build in a little bit of tolerance like for example, 4 decimal places, you go 0.0186, but if you accidentally type in like 0.0187 or 0.185, like I'll accept those. Like I'll build in a little bit of a error tolerance. Okay. Does that ring a bell? I know we did that probably 5-6 weeks ago, but does it ring a little bit of a bell?
Yeah.
People
Yes.
kind of remembering the normal CDF stuff. Okay. All right, let's do 2 more questions related to this. Is everybody okay if I move on?
Yeah.
Yep.
Yeah.
Okay. So what is the probability of the sample mean from the sample of these 100 young couples who are living carefree, probably childless and don't know what lack of sleep is like, will result in a mean credit card debt of less than $630? So it's the probability that this X bar, nobody found my little commentary there funny?
Too true to be funny.
Yeah. So it's probably that X bar is less than $630. So again, you don't have to do the drawing, right? Like there's no scrap paper for you to show it to me, but like it just helps me, you know. So it should be centered at 650 and I want to be less than 630. So I want to shade all the way to the left. Okay. So this is normal CDF. Since this is a left-tailed, what's my lower here?
Negative 99999.
Negative 99999. Yep. And then what's my upper? Where does my
630.
Yep, 630. And then the mean was 650. And the standard deviation there was 24. So you just go back and go second function distribution, and you just always use the normal CDF. Okay, normal CDF minus 99999, comma 630, comma 650, comma 24. Close the parentheses, and you should get this 0.2023. Everybody else get that?
Yep.
Yeah.
Awesome. All right, next question. What is the probability that the sample mean, okay, is of these 100 young couples will result in a mean credit card debt between 640 and 660? So you're centered at 650. And I want to be between 640 and 660. Weird numbers to pick, but that's what I picked. I'm going to shade this in. So again, just normal CDF. So it's a between. Okay, so what's my lower here?
640,
Yep.
640.
What's my upper?
660.
Yep. 660. Yep. And then the mean and standard deviation don't change. Okay, it's still 650 and 24. So I'll do this one in the TI-84 here. So 640 to 660. The great thing about the TI-84 is it leaves the mean and standard deviation in there for you. But if you had the TI-83, you just would have typed this in. And you get something like this. So 0.3231 when I round it. So again, if you just put in 0.3230, I'll end up accepting it and giving you credit for it. So it's 0.3231. And that's the answer. All right, so the first problem on your exam is going to look like this. So I'm going to be honest with you. The only thing I can do is change the numbers. Okay, the process is still exactly the same. Okay, so the big thing here to remember is just going back. You take the standard deviation and you divide it by the square root of the sample size, and you use that. Okay, as for the standard deviation. So don't make, just recognize that on the exam. Okay, don't make that error. Okay. Everybody feel like they could knock this type of problem out of the park?
Yep.
Yeah.
All right. And, remember, you're going to have this handy, your notes handy on the final. I'm also going to post these slides. I'm recording the lecture and I'll post them here shortly after class for you. So, honestly, I would have this printed out for you as well. Keep this handy with you. Okay, everybody ready to go to the next problem?
Yes.
One yes?
Yep.
Okay.
Yeah.
Dun, dun, here we go. All right, so this one is about sampling distribution for the proportion. So ultimately, you're going to use the normal CDF thing again, okay? Just like the notation is a little different and how you find the mean and standard deviation, there's a different formula, okay? So as of 2007, so this is a while ago, all right, the United States Census Bureau reports that 27% of the population has attained a bachelor's degree or higher, okay? So P, the population proportion of people who have a bachelor's degree or higher is 0.27. And then it says, suppose a random sample of 200 adults is obtained. So that's your sample size. Okay. And basically what you're going to do is you're going to talk to 200 people and you're going to record how many of them have a bachelor's degree or higher. Okay. And you're going to get the proportion here. So next it says, describe the sampling distribution of p hat, the sample proportion of adults who have a college degree in the 200 people. Okay, so just so we're clear, I'm going to just define that fully. So we're going to let p hat equal the sample proportion in 200 adults who have a college degree. Okay. And look, so I want to describe the sampling distribution. Okay, so basically what you want to do is you want to say it's normally distributed. Okay, so there was a number check here. And the number check was you take n times p times 1 minus p. And does anybody remember what that has to be greater than or equal to?
10.
That's it. Yeah, 10. So look, you have n and p right here. Oops. So you take n, which is 200, times p, which is 0.27, times 1 minus p, so 1 minus 0.27. And you get this, 39.42. Which is greater than or equal to 10. Okay. So I'm just going to tell you something. You don't actually have to do this number check on the exam. It will always check out. Okay. What's really important is you say what the mean and standard deviation is. So we can say thus the sampling distribution of p hat is normally distributed with mean, we denote it as mu sub p hat. Does anybody remember what that's equal to? So it's always equal to the population. Yep. So it's equal to 0.27. And now the standard deviation is a little bit harder. There was a formula for that, okay? It was the square root of P times 1 minus P over N. Okay? So everybody, when I go to do this, I really encourage everyone to take their calculator out and follow along with me, okay? So it's 0.27 times 1 minus 0.27 divided by 200. So I'll do it in the TI-83, and then I'll also do it with the TI-84 so we can see that how you do them differently. Okay, so you're going to go second function square root. You're going to go 0.27 times, and then in parentheses, you're going to start a new set of parentheses, 1 minus 0.27. You're going to close that set of parentheses here. Divide by 200. But on the TI-83, you have to make sure to close this final set of parentheses. Whoop, right here, okay? How many people got that number right there?
I got that.
Yep.
Yep, okay. So I'm just gonna do it in the TI-84 so you can just see the difference here. So square root 0.27 times in parentheses 1 minus 0.27, close, divided by 200, and you get the same thing. Okay. So I'm going to go out 4 decimal places. Don't worry, on the exam, it'll say exactly how many decimal places for you to go out. So 0.0314 when I round it. Okay. So now what I'm going to ask you is I'm going to ask you some probability questions, okay? Probability. All right? It's always just going to be the normal CDF, okay? That's it. So what is the probability that less than 25% have a college degree? So it's the probability that P hat is less than 0.25. So guess what? I'm not even going to draw this one because it's so straightforward once you get here. It's the normal CDF. Okay, so lower, upper, mean, and standard deviation. All right, when I have a less than probability like this, what's my lower value?
Negative
Minus
9999.
Yep, negative 99999. And I want to stop at what number here? What's my upper?
0.25.
Yep, whatever's right here, 0.25. And then my mean and standard deviation are these two values here. So it's 0.27, comma 0.0314. Come on. So second function distribution, normal CDF, negative 99999, comma 0.25, comma 0.27, comma 0.0314. Do you get something like this?
Yep.
0.2621 when I round it. 0.2621. Yep. Do we recall doing this problem? Something like this?
Yes.
Yeah.
Okay. Now that you've seen me do one, coming back and you think you can handle this on the exam?
Yes.
I got one yes.
Yeah.
I get good vibes. I think you'll all do great.
Yes.
All right, let me just do 2 follow-up questions to this, okay? In a random sample of 200 adults, what's the probability that more than 28% have a college degree? So it's more than. So it's probably that p hat is greater than 0.28. Okay. So normal CDF, if I have a greater than, what's my upper going to be?
0.28.
Yep. Or excuse, what's my lower going to be? Sorry. Thank you. First thing is 0.28. And then what's my upper going to be? Sorry.
9999.
Yeah, 9999. Sorry about that. And then the mean is still what I had before, which was 0.27. And then the standard deviation is 0.0314. So I'm going to grab my TI-84 to do this one. So second function distribution, normal CDF. My lower is 0.28. My upper is 99999. You should be at 0.27. And the standard deviation doesn't change here. How many people got this? 0.3751.
Yeah.
Yeah, I did.
I got it.
All right, 0.3751. Okay. So this question here, just this next one just involves an extra step. And for as long as I've been doing this teaching this stuff, this is the question that if someone's going to miss on this part, they're going to miss this one. So in a random sample of 200 adults, what is the probability that between 48 and 56 have a college degree? So do you notice how the 48 and 56 are not percentages, they're just numbers? So what do I have to do with them?
Make a percentage.
How? Yep, you're exactly right.
Divided by 200.
Yeah. So I'm not giving you the raw numbers here. So you just got to take this and divide it by 200 to get the sample proportion, which I think is 0.24. And then the same thing for 56. I think you get 0.28, right?
Yes.
Yeah, I think I did that right in my head. Yeah. So now you just be between those. So it's the probability that you're between them. So 0.24 less than p hat, less than 0.28. So normal CDF, the lower here is the first value, 0.24. The upper is the second value, 0.28. The mean was 0.27, and the standard deviation is 0.0314. So second function distribution, normal CDF, 0.24 to 0.28, comma, 0.27, comma, 0.0314. Do you get this? 0.4553 when I round it?
Yep.
Yeah.
0.4553. Not too bad.
Nope.
All right. Think you'll be okay to handle one of these on the final?
Yes.
Okay, good. So the only thing that's going to change is like the numbers, right? Like the process, this normal CDF, that's just never going to change. Okay.
When you ask us to describe the sampling distribution in terms of like Blackboard, is it going to just be multiple choice or?
Yeah. So here's what's going to happen. Like the problem will say something like this. We know the sampling distribution of p hat is normally distributed. What is the mean of this sampling distribution? And then there'll be like a multiple choice with 4 options, and you'll just have to pick out this one. Okay.
Okay, got it.
And then it'll say, the next part will say, what is your standard deviation? And there'll be 4 options. You have to pick one. And then what the next part will say, it'll say, in a random sample of 200 adults, what is the probability that less than 25% have a college degree? And it'll say something next, like use the values you selected above for the mean and standard deviation.
Hi, Professor. I got late to the meeting,
That's
and
okay.
do we have to upload our work, or is just the Blackboard?
It's just Blackboard. You won't have to load up anything.
Awesome. Okay.
Yeah. There's just so many technical issues, and like it's a
Yep.
time test. I just don't.
Mm-hmm.
We won't do that. Do a lot of your instructors make you guys load up stuff?
Just one professor, and it was a mess, a total mess.
Okay. I'm sorry. I mean, sometimes it's okay.
Yeah, I mean, he gave us a little more time because people, there was old people on the class, and they didn't know how to do it, so that make that difficult. So.
Well, don't. I'm gonna be an old person. I'm an old person.
No.
So, all right. What we're gonna do now, we just have confidence intervals and hypothesis testing next. We're gonna take a little bit of a break, just for 5 minutes. I just want to go refresh my coffee. Okay. So back at let's do. We'll just say 10. We'll take a 7-minute break. Or 9:50. Sorry. Is that okay with everybody?
Yep.
Sounds
Yes.
good.
All right.
Yeah.
I'll be back in 7 minutes.
Get on break.
You're unmuted, Denise, just so you know.
Oh my God. Thank you.
All right, everybody. Just everybody can hear me okay?
Yeah.
Yeah.
Yep.
Yes.
All right, I got a fresh cup of coffee. Let's finish up. So the next two topics should be should go a little bit quicker because they're a little bit fresher in our mind. I wanted to spend more time on the other ones. But again, for all these next problems, we're going to rely very, very heavily on our graphing calculator. Okay. So here's the next problem. So it's about confidence intervals for a mean. And it goes like this. Suppose an economist wishes to estimate the mean commute time of workers in Westchester County. Great. So what the economist does is the economist obtains a random sample of 31 commuters. So I'm going to write that down. So n is equal to 31. And finds the sample mean, x bar, to be 31.2 minutes. All right. I used to say, when I used to do this problem, because I drove all the way from Jersey to work, I used to be like, oh, that's not a bad commute, but like my commute these days is just the best. And sample standard deviation S of 12.1 minutes. Okay. So the first part says construct and interpret a 90% confidence interval for the mean commute time in Westchester County. All right, so it goes like this. Do you think the actual average commute time in Westchester County, New York is exactly 31.2 minutes?
No.
No, it's not. It's
No.
not exactly. It's probably close, but it's not 31.2 minutes. So what could it be? So we need a confidence interval for that. So at this point, it doesn't matter if you have a TI-83 or TI-84, they look the same. But for the confidence interval for a mean, okay, you're going to use your calculator, right? So everybody, trust me, please just grab your calculator, have this handy, okay? I'm going to press the stat button on my calculator, stat. I'm going to scroll over to tests, okay? Did anybody remember what I have to do for this, or what option it is?
8.
It's option number 8. Yeah, so it's the T interval for this confidence interval. So it's option number 8. So let me write this down. So I went stats, stat button. I went over to tests. And then I went and found option number 8, which was called T interval. Okay, stats, tests, T interval. So click on number 8 there. So you have two options here. One is for data, like if you're going to plug the data into your calculator. But for this problem, what I do is I just give you the stats. Okay, so I'm going to scroll over to stats here. I'm going to hit enter. And now all you have to do is just like super easily plug these values in. Okay. X bar is 31.2. So I'm going to go 31.2. It says S, well, that's 12.1. And N is my 31. So you have to be careful here. So what confidence level did I ask for here?
0.9.
Yeah, so
90.
it defaults to 0.95. So I just have to change it to 0.9. You can put 0.90. I'm just going to put it as 0.9 though. And then you're going to hit calculate. Seriously, calculator? Okay, there we go. I've never seen the calculator take that long.
That was weird. Mine did too.
Mine did the same thing.
What?
The same with mine. That's kind of weird.
Yeah, it never took this long.
Right? And it just, something's going on. Something wacky's going on because it affected everybody's calculator. Oh, that's weird. That's super weird, right? I'm not the only one who thinks that's
Maybe
weird.
the values you think it is?
I mean, it has to be something. You know what?
Yeah.
I don't want to think about it because then I'm going to get a little spooked out about it. All right, but how many people got this on the screen here?
Yep.
Anybody else?
I did.
Yes.
Yeah, so this is
did.
good. So your calculator just did this problem for you, okay? So it says the lower bound is 27.511 and the upper bound is 34.899. Oh God, I can't remember anything these days. Okay. So I'm just going to interpret this one for us, okay? So it just goes like this. Based on this sample, we are 90% confident that the mean commute time in Westchester County is between 27.511 minutes, and it could also be as high as 34.889 minutes. So relying on your calculator for this, does this just make it like super easy?
Oh yeah.
Yeah.
Honestly, you all should just like, I don't know why I'm filled with baseball references today, but you should knock it out of the park on this one, okay? Or you should hit a 3-pointer on. That doesn't sound as good. Throw a touchdown doesn't sound as good, but just hit a home run on this one. Okay. The next one here, I'm just going to construct a 95% confidence interval here. So the only thing that's going to change when you plug this into your calculator is the confidence level. So again, you're going to use the stats. You're going to go stat. You're going to scroll over to tests. And it's option number 8 again. Okay, T interval. So again, you're going to have your stats. And you just have to plug them in again. Okay. 31.2, 12.1, 31, and then just make sure your confidence level matches. Okay, it's 0.95. And the calculator did it again. And how many people got this, see this on here, on theirs?
I got the same.
Yes, got it.
Yes.
Did everybody's calculator take a while again?
Yep.
Yeah.
Oh man, this is so freaky. Okay. So the confidence interval is 26.762 all the way to 35.638. Okay. So there's your 90. Notice how if you want to be more confident, go from 90 to 95, the interval gets wider. Okay. But just rely heavily on your calculator. You know, I've shown you guys how to do this by hand, but honestly, you know, no one does it by hand in the real world. So, you know, rely on your technology when you can to do this for you. Okay. I think that one's a piece of cake. All right. Hopefully everybody gets this one on the exam and doesn't miss it. All right. So just so you know what'll happen on the exam, you'll have to pay real close attention to this. This problem, if there's 2 confidence intervals, will actually be 4 questions. The first part will say something like, what is the lower bound of a 90% confidence interval? So you'll have to put this in. And then the follow-up question will say something like, what's the upper bound to the 90% confidence interval? And then you'll have to put that in. Okay. Everybody okay if I go on?
Yes.
Yes.
Okay.
Yeah.
All right. So for random sample of 1,000 Americans, it was discovered that 920 of them lived in neighborhoods with acceptable levels of carbon monoxide. Okay, this was from the Environmental Protection Agency, which is just straight up scary right off the bat because 80 people didn't. So that's all you're given here. So your sample size N here is 1,000, and X, the number of people who live in neighborhoods with acceptable levels of carbon monoxide, was 920. Okay, so the first question says, obtain a point estimate for the proportion of Americans who live in neighborhoods with acceptable levels of carbon monoxide. The point estimate here is just p hat. Okay, does anybody remember the formula for that?
X over
X
N.
over N.
Okay. So it's just 920 over 1,000 or 0.92. Okay. So again, you know, this goes down to is like, all right, it's not exactly the proportion of Americans who live in neighborhoods with acceptable levels of carbon monoxide is not exactly 92%. So let's construct a confidence interval then for the proportion of Americans who live in neighborhoods with acceptable levels of carbon monoxide. And the first question says, do a 90% confidence interval. All right, so everybody grab their trusty calculator here. Oh, come on. This calculator keeps bugging out on me. So to do this, again, we're going to rely very heavily on our calculator. So everybody hit the stat button. You're going to scroll over to test. And then does anybody remember what this one was called?
Is this the Z interval number 7?
So nope. So the Z interval number 7 has to deal with confidence intervals for a mean when the population standard deviation is known. But it does involve a Z.
Oh, it's the 1 prop Z.
Yep. So everybody scroll down until you see 1 dash prop Z int. So it's a 1 proportion Z interval. So we went, come on, pen. So we went stats button. We scrolled over to tests. And then it was 1 dash prop Z interval. So Z int. So those were the options you're looking for this one. Okay. So here you're just going to hit enter. And then this one is like incredibly easy. Okay. It just says, all right, what's your X? Well, there were the 920 people. All right. What's your N? 1,000. And then just make sure to change your confidence interval. And then how many people see this number right here?
Yep.
Yes.
Yeah.
Yep. So it just says go to 3 decimal places. So it's 0.906 to 0.934. And that's your confidence interval. Okay. So we're 90% confident that the proportion of Americans who live in neighborhoods with acceptable levels of carbon monoxide is somewhere between 0.906 and 0.934. All right, so the next one says construct a 90% confidence interval for the proportion of Americans who live in neighborhood 99 live in neighborhoods with acceptable levels of carbon monoxide. So again, it's going to be the same options. Okay, you're going to hit the stat. You're going to scroll over to tests. You're going to go down to 1 dash prop Z interval right here. And then what's the only thing that I need to change?
The confidence intervals.
level.
Yep, to 0.99. And you should see this. So all I did,
Yes.
I went a little faster. I'm sorry. You just had to make sure to change the C level, the confidence level, to 0.99. And you should see this. So it should be 0.898 to 0.942. And that's it. So your calculator's just like rocking this exam for you so far. Okay. Everybody feel like they could do this one really well?
Yes.
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 Okay, good. All right, everybody okay if I move on?
Yes.
Yep.
Yes.
Yes.
Okay, I just want to do this real quick. All right, so your final topic is going to be about, your final 2 questions will be about hypothesis testing. So there were two methods for hypothesis testing. Okay, one was called the critical value approach. And one was called the p-value approach. Just out of curiosity, which one did you guys think was easier?
P-value.
Yeah. Anybody else agree?
Yeah.
Definitely p-value.
Yes.
Yes. Okay. So your exam is going to be all p-value questions. Okay. Okay. Basically, we do the p-value approach. Number one, because that's how it's just done in the real world. No one uses the critical value approach. Everyone does the p-value approach. And also your calculator just does this for you. And I mean, honestly, why make it harder on ourselves, right? So in hypothesis testing, there's two things you can do. You can reject the null. Or you can fail to reject the null. Okay, so you reject the null hypothesis when the p-value is less than the level of significance. Okay, you fail to reject the null when the p-value is greater than the level of significance. Okay. So we're going to obviously rely very heavily on our calculator to do this. Okay. So if you guys remember, I gave you a 5-step process on it. Does everybody remember the 5-step process approach?
Yes.
Yeah.
Okay. So basically on the exam, really what I'm going to ask you on is, I'm only going to ask you 3 parts to it. Okay. I'm going to write out all 5 steps on the, in the notes here, but the exam's only going to ask for 3 things. Okay. The exam is going to ask for you to set up the test. What is the test p-value? And then if you reject or fail to reject the null, that's what's going to happen. Okay. So I'm going to do 2 examples. And I'll walk you through everything. So everybody ready to go to the next question?
Yep.
Yes.
Yep.
Okay. I'm gonna have a sip of coffee first. Okay. So here's the first question. Does playing Mozart for unborn babies result in children having higher IQs? So the reason I picked this problem was, does anybody remember like maybe a decade ago, they had this big thing called Baby Mozart?
Yep.
One person remembers it. Yeah.
Yeah.
I have a 9-year-old. That's why.
That's why you were, yeah, right. So there was this big push. I mean, I have like a lot of baby Einstein toys in my house already. Not all for my kid. Some are for me. That was a terrible joke, actually. They're all for him. But so there was this like big push a while ago, like a decade ago, that said, look, if you just play Mozart for your kid, when they're during their gestation period, it'll like make them smarter. Right. So does anybody remember that claim?
Yes.
Yes. Okay. One person. Obviously, because you and I have kids, we remember this claim. And so this was a marketing scheme by this company for a long time. And you'll notice, and this is kind of giving away the hypothesis test right now, but like you'll notice that that's just not a thing anymore. Okay. I don't know if I'm a bad father or not, but we played a lot of Beatles music for my son when he was, my wife did. We didn't play any Mozart. So here's the problem. Okay.
Did he come out with a Liverpool accent?
Did he come? Oh, good joke. No. But he came out crying like he had just taken a jet lag plane from Europe though. But that was funny. Good question though. No. So a psychologist obtains a random sample. So I'm going to write down what's given. So you're given 20 mothers in their first trimester of their pregnancy. And the mothers are asked to play Mozart in the house at least 30 minutes each day until they give birth, just so like the kids can hear Mozart. Okay. So then after the kids are born, they're given an IQ test like a few years later. Okay. So we know that IQs are normally distributed with a mean of 100. So, you know, IQ tests measure intelligent quotient, and it's just one type of way to measure intelligence, right? Like IQ tests don't necessarily tell you if you're really smart or not. They just measure a very specific type of intelligence. Okay. So that's one thing. Okay. So if the IQs of the 20 children in the study result in a sample mean, so X bar is 104.2 and a sample standard deviation S of 15. Okay. Is there evidence that the children have higher IQs, okay, at the 0.05 level of significance? Okay. So you're given that alpha there. Okay. So we got to do a hypothesis test to see if basically what's going on here is if that kids listen to most Mozart in the gestation period, that they're end up being smarter and later on in life. What type of keyword in here gives away if it's a right-tailed, left-tailed, or two-tailed test?
Higher.
Yep. So we want to see that it's higher. So this tells me it's going to be a right-tailed test. Okay. So we just got to go through and solve this, okay? So step one. Okay. The first thing you have to do is define a parameter. Okay, so we're going to let mu be equal to the mean IQ of what? Children whose parents did what?
Listen to Mozart or
Yep.
had their babies listen to Mozart.
Yep. So mu is going to be the mean IQ of children whose mothers listen to Mozart at least 30 minutes a day until kids were born. Okay, so it's very specific, okay? And then I know it's a right-tailed test, okay? So it's going to be mu is equal to something versus mu is greater than something. Okay. So this is the tricky part. You have to figure out how to set up this test. What do we want? We want to say to test to see that they have higher IQs. Okay. So it's going to be higher IQs on average. Okay. So does anybody know what value we're going to put in the null and the alternative there?
Is that the 104.2?
So that's the sample mean.
Oh, the 100. Sorry, I can see it now.
Yep, yep. So here's this, honestly, for as long as I've been teaching, this is the hardest part here, setting this up. So what is the average IQ score just in general for the population? What does it say?
100.
Yeah. Okay. So, you know, what we're going to say is, look, we want to see that if they've listened to Mozart, that they're smarter on average. So we'll start with the assumption that nope, Mozart doesn't matter. Okay, it's equal to 100. And what we're looking for evidence to show is no way. No way. You listen to Mozart in the gestation period, you're going to be so much smarter that it's greater than 100. Step 2, you're going to select your level of significance, which is 0.05. So just so we're clear, let me go back here. So on the exam, what's going to happen is step 1 is going to be a multiple choice problem. I'm going to set up a bunch of options for you to select, and you're going to have to select the right hypothesis test. So you're not going to have to write it out, just so we're clear, like this, okay? Like I'll give a bunch of options where it's like mu is equal to 104.2, mu is less than, you know, I'll give you a bunch of different things to select, and you'll have to select the right hypothesis. Okay, step 3 was critical value. And step 4 was compute the p-value. So the good news is your calculator will do this for you. So everybody grab their trusty calculator. Oh my God, this calculator is terrible. I'm just going to switch to this now. And what you're going to do for this, for steps 3 and 4, you're just going to press stat. You're going to go over to tests. And does anybody remember what option this is?
One property test.
Nope, because this is you're close. It's definitely a type of test, but like, are we talking about a mean or a proportion?
Mean.
It's a
Mean.
mean. So whenever you have a hypothesis testing for a mean, it's option number 2, t-test. Okay, so I'll even write this up here just so we're clear. It was stats, the stat button, then you went over to tests, and then you select this t-test, t-test. Always, 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 okay? So just as a hint, like when you see this problem on the exam, you're just gonna go boom, right to those options. So it's option number 2. And what I did is I give you the summary stats. So you're gonna click over to stats. And now you're gonna have to input a lot of stuff. And this is where it gets a little tricky. Okay, mu sub 0. Okay, that's the mean from the null. I'm trying to, okay? So that's 100. Okay, that's whatever you had in the null hypothesis. The X bar is 104.2. S sub X is the standard deviation, which is 15. And then N is the sample size, which was 20, okay, which was right there. And then what you're gonna have to do is you're gonna have to make this mu here, you're gonna have to set this so it matches the null hypothesis, okay? Right here. All right, how many people are with me on their calculator so far?
Yep.
Yeah.
Okay.
I-
Okay. So at this point, the calculator is just going to solve the problem for you. So you're going to scroll down to calculate. Okay. So the null, sample mean, sample standard deviation, sample size, and then select the alternative that matches your test. And you're going to hit calculate. And you should see something that looks like this. Okay. How many people have this?
Yep.
Yeah.
I
Okay. So this T thing here, this is your test statistic. It's 1.252. Or your I put critical value here. I meant test statistics. Sorry. Jeez. I'm so sorry. It's getting towards the end of the semester for me. Sorry about that. I didn't mean critical value. That's a big goof. I'm sorry. It's the test statistic. And then the p-value here is right here, 0.1128. I'll go out 4 decimal places, 0.1128. Okay.
So the proportion test statistic would be Z.
Yep, I'm going to do that next. Actually, I have a problem set up next for that. Okay. But I'll walk you through that. But to answer your question, yes. Okay, so on the exam, what I'm going to ask you next, I'm not going to ask for the test statistic. I'm going to ask you to tell me what the p-value was. Okay, so you're going to just pull that right from your calculator. Next, step 5 is your conclusion. Do we reject or fail to reject?
Fail to reject.
Fail to reject.
Yep, the p-value is greater than level of significance. So we fail to reject the null. So what that means when we fail to reject the null is that the evidence does not suggest that the mean IQs of babies who listen to Mozart are higher on average. Okay, that's why, I know the one other person here who has a child, we heard all these studies, decades ago, like, oh, listen to Mozart. But that's why they just don't say that anymore. It's just like, yeah, just, listen to music that gets you through the day. Okay. And in my household, it is generally Broadway tunes. A little bit of information for you.
We've got Hamilton on right now.
I am so sick of Hamilton. Because I listen to it so much.
Never.
I have a funny Hamilton story just for a quick sidebar. I took my wife to see Hamilton. This was before it blew up, so I could afford the tickets. I was in the audience. We had the worst seats in the house. Like literally our backs were against the back wall. But we actually saw the play with Kanye West and Kim Kardashian. So when I go to leave, like my wife is like, oh, let's go to the back door. Let's go to the back door. And there's Kanye and Kim Kardashian standing there waiting to see the Hamilton people.
Cool.
That was really weird. It was really, really weird.
Say hi to him.
Did I say hi to them? No, I didn't. But it was so funny. Like they got into the car next to me and I'm like looking into the glass window and there's, right in the car next to me. I'm like,
Oh my
this
God.
is so weird. All right, but
Celebrities, they're just like us.
they're just like us. They just had better seats in a nicer car. But it was just really, really funny. I have a number of celebrity sightings in the city. That's not even.
I've never seen any.
Oh, the best one. My favorite celebrity story sighting. I'm just going to tell you one last one. We were going to see a play in the city, and my wife and I are in line, and this person comes up behind my wife and kind of like pushes her to like get her out of the way, because he wants to go behind her. And my wife is just like, she gets pushed a little. She's like, "Excuse me, buddy," like gives him a lot of attitude. And she looks at me. She's like, "Oh, what an a-hole." And then I turn around and it's Billy Crystal.
Oh God.
He probably
What do you
is.
say?
Probably is an a-hole.
he didn't do anything. We just kept walking because my wife didn't turn around to see who it was. We get inside and I'm like, "Hey, that was Billy Crystal who pushed you." And she's like, "What? Why didn't you tell me?" Oh man, I have some other fun. Yeah, I don't have any normal celebrity sighting stories. They're all like funny. Okay, you know what? Who cares? Let's go and do the last problem. All right. Hypothesis testing for a proportion. Okay. So here's the problem. Labor Day, okay, in September was created by the US labor movement 100 years ago. Okay. So it was subsequently adopted by most states as an official holiday. Great. So in a poll by Gallup, okay, 1,000 randomly selected adults, 1,000, okay, were asked whether they approve of labor unions. Okay, so we have a national holiday for the labor movement, but how many people actually approve of labor unions? And 650 said, yeah, labor unions are good. So here's a question. In 1936, so this is a while ago, okay, 72% of Americans approved of labor unions. Okay, so I'm telling you for whatever reason that in 1936, 72% of Americans said, yeah, labor unions are great. So at the 5% level of significance, Do or does the data provide sufficient evidence to conclude that the percentage of Americans who approve of labor unions now has decreased since 1936? Okay. All right, so we're going to do a hypothesis test here. What's the key word?
Decrease.
Decrease.
Right-tailed, left-tailed, or two-tailed?
Left tail.
Left-tailed.
Yep. Left-tailed test. Now I can't. Now I'm smiling. No, I can't stop thinking about my celebrity stories. You know, sorry.
Tell us at the end.
Yeah. So I give you the level of significance again. It's alpha 0.05. Okay, so let's just go through this. Step one, we're going to set up the test. All right, so we're going to define a parameter. So it's a population, it's a hypothesis test for proportion. So we're going to let P be equal to something. And what proportion are we investigating right now?
Percentage of Americans who approve
Of what and when?
of labor unions since 1936.
Yeah, so now, so what proportion approve labor unions now? Yep, so it's the proportion of Americans who approve of labor unions now, okay. So in 2020, worst year ever. And it's going to be, you said, a left-tailed test, everybody said. Okay, so it's P is equal to something and our alternative is no way it's less than that number. Okay, so what assumption are we going to make? That P is equal to what? And we want to see that it's less than that number.
That P is equal to 0.72.
Yep, so we're just going to assume that it's the same as it was in 1936. And what we're like, no way. It's definitely gone down. Okay, it's less than that. And step two, level of significance, we got it. 0.05. Step three is the test statistic. And step four is the p-value. Okay. And we're going to use our calculator for this. So I'm going to grab my trusty calculator. And what you're going to do is you're going to hit stat. You're going to scroll over to tests. And which one is this now if I want to do a hypothesis test for a proportion?
This one's the one prop Z.
Yep, it's number 5, 1-prop Z test. Okay, so I'm going to write this down here. So we went the stat button. We went over to tests. And then it was 1-prop Z test. Okay, that stands for a one proportion because we only have a single proportion we're testing. We're using a Z critical value and it's a hypothesis test. So it's option number 5 here. So at number 5, I'm just going to hit enter. And it's super easy. Okay. P sub 0 is what you have in your null. So it's 0.27 or 0.72, sorry. X is the 650 people who said they supported labor unions. N here is the sample size of 1,000. And then you just have to make sure that you select the right test, okay? That you have less than, okay? So you're gonna make sure that that's selected. And then you're gonna go down to calculate. How many people see this on their screen?
Yep.
Yeah.
Yep.
Yep. All right, so I'm going to explain. Everyone see 4.116 and then e to the -7?
Yes.
Yes.
Yeah, I'm going to explain what that is in a second. Okay. So what Z is the test statistic. It's minus 4.930, okay? All right, so this is super weird. This p-value here. Does anybody know what the e to the -7 means?
Yeah, times 10 to the -7th.
Yeah. So what this basically means, when you see this e to the -7, it means take this decimal place and move it whenever it's negative, it means move it to the left 7 places. Okay. So my p-value is 0.0000.6 zeros than a 4. Okay. I just wanted to do this one here. I'm not gonna the one on your exam doesn't have this crazy thing here, but I just wanted to do this in case, in the future for you.
We did have that for the assignment, I think.
Oh, did we?
I think it came up to the e to the -5 or something in the
Okay.
assignment,
Okay.
if I'm not mistaken, but I think it was.
I'm sorry about that. Hopefully it made sense. So I'm just in full disclosure, to be honest with you. When I teach in person, I teach the critical value method. So like, it's so obvious here with the critical value method, what you do. So I just haven't updated some of the problems just because we're remote, like the p-value is just so much easier. But anyways, my apologies for that. Thank you for letting me know. I'll grade the assignments a little bit easier as a result.
No worries.
Okay, so step 5, what's our conclusion? Reject or fail to reject?
Reject and all?
Yeah, is my p-value less than my level of significance?
Yes.
Absolutely. So we reject the null. And what's going on here is evidence suggests that the proportion of people who support labor unions has decreased since 1936. And that's it. What do you all think? You think you'll be able to do well on the exam?
Yep.
Knock it out of the park?
Yes.
Yeah.
Grand
Yes.
slam in this.
This even better than a home run. You'll grand slam it.
Yep.
Okay, so what I'm going to do now, we're going to end class just a little early. So what I'm going to do is I'm going to, I'll post the recording. I'll post the record. It's just going to take me about an hour or two to get it up on YouTube, and then I'll shoot an email. I'll make sure I don't forget it today. And that's it. Yeah, I'm going to stop the recording for a second.